Hello, this is Mrs. Taylor, and I am going to review how to do number 9 from your exponential functions study guide. The question reads, the function f of x equals 12 times 2 to the x power models an insect population after x weeks. So x represents the number of weeks. To the nearest whole number, what will the population be after 5 weeks? So if x represents the weeks, and they tell me 5 weeks, that means that I would make x equal to 5. So the way we can notate that is instead of writing f of x, we write f of 5. And that shows that I'm substituting 5 in for x. My input would be 5. And I rewrite my equation with the 5 substituted. The nice thing about calculators is they will do all the hard work for you when it comes to evaluating. So all I have to do is 12, and in the parentheses put the 2 to the 5th power, and then press enter. And that gives me 384. So in 5 weeks there will be 384 insects. Now that is the first part. Over here on the right side, it says now graph the function. So what I need to do is generate a table of points to plot. So the way I'm going to do that using my calculator is I'm going to go to y equals, clear out what's there, and type in this equation. So 12 to the x power. And you want to use the equation that has the x so that when your calculator uses this to generate your table, it'll generate your y values for any possible x value, not just the 5th week. So second table, that gives me some points to plot. And looking at my table, my y values go all the way to 500. So it looks like they want us to get pretty big. And then if you look, your x axis only starts at 0, and so it makes sense. If x is the number of weeks, you don't have negative number of weeks. So I don't really have to worry about -3, -2, -1, any of those negative values for my table. I can just start at 0. So it would be 0, 12, 124, 248, 396, and then scroll down. Do a few more. 4, 192, 5, 384. And then I'm going to plot those points. So 0, 12, be really low. 124, kind of almost be halfway. 248 would be almost to 48. 396. Almost to 100, 4, 192, almost to 200, and 5, 384, almost to 400. Now the question is, do we connect them? Well, if you think about it, would you have growth of insects in between the weeks? Like, you know, would there still be growth happening between the starting point and 1 week? Yeah, 1 week's just the total. So we would connect this because you have growth consistently throughout the time period. So that would be how you would find the population after 5 weeks and then graph your function.